Hello everyone and welcome. In this video, I'll show you step by step how to create a custom footprint in KiCad. We start by setting up the footprint with proper naming conventions and a datasheet link. Then move on to creating and positioning the pads and finally finish with the outline courtyard and pin 1 designator. By the end of this tutorial, you will have a complete workflow for building your own footprints from scratch. The first thing I'm going to do is create a new empty footprint and select a cursor grid. I just need to move the reference and footprint name a bit to the sides so they don't disturb while working. The next thing is we are going to open up the footprint properties and go to the value field and enter the footprint name. KiCad defines how to name a footprint in the KiCad Library Conventions. I already worked the name out based on the package, the pitch, and the general dimensions of the footprint. And I'm just going to paste it in the value field and as the footprint name. In the description, I simply enter the FN6 and then head to the datasheet link and copy the datasheet link and paste it in the description. When pasting the link in the description, KiCad automatically opens the datasheet when pressing Ctrl D in the footprint editor, so you can use it as a reference. The KiCad Library Convention also requires us to specify a path to a 3D model, even if it does not exist yet. This way, the 3D models are loaded when somebody submits such a 3D model. And I'm also just going to paste the path. Obviously, no 3D model is loaded because it doesn't exist. I didn't provide one. That's it for the setup. We head to the default pad properties. The pad type SMD is already connected. We want to have the first pin. We have to select the pad size. The pad size of 0.6 by 0.4 is already set correctly from the last time. I'm just going to press OK. Now I use the Add Pad button and place it on the 0, 0 coordinate. The KiCad Library Conventions and several IPC standards require us to place the pad in the top left corner. So that will be in the coordinate where the X and Y values are negative. I'm just going to press E to open up the pad properties. KiCad does actually do the math for us. So when looking in the drawing, we see that it's 1.7 millimeters between the different pads from each direction. And obviously the 0, 0 location needs to be the middle point of the component, or rather where the component is being picked up by the pick and place machine. Obviously, this is simple math, but I just want to demonstrate it. We can go 1.7 divided by 2 because we are working from the middle of the component. 1.3 divided by 2. And I have obviously need to have those values in the negative, so the pad is placed at the right location. Now we could do this manually for all pads, especially since it's a rather simple component with only 6 pads and an elf pad. But I just wanted to show you a quick way to save some time with larger components. So we are just going to select the pad, right-click, create from selection, create array. This allows us to create arrays of pads and save time. So because we have just 2 rows on the outside of the component, we are just going to do horizontal count 2, vertical count 3. Our horizontal spacing is 1.7. Our vertical spacing is 1.32. Then we're just going to the source item remains in its place. We do vertical, then horizontal, and then reverse the number scheming, because that is also the pad numbering over here. Just going to click OK, and we have all our 6 pads quickly created. Now I place one pad in the middle and press E, and then simply change the pad size to the required size. Now we have to draw the component outline on the fabrication layer. Because we are on the front, it's f.fab for front fabrication. The component is 2.5 by 2.5 millimeters. And while we could draw this accurately, I'm just going to quickly draw it roughly and then use the edit option again, because that allows me to be quicker. And that's 1.25 and 1.25. And now we have the body outline drawn correctly already. So we are just going to select that, right click, create from selection, create outset, and that creates the courtyard. The outset of 0.25 millimeters is correct, but we do not want to copy the item because according to the KiCad Library Convention, they need to be 0.05 millimeters. If you would copy it, it would be 0.1 as on the fabrication layer. We simply click OK, and we created our courtyard quickly. Now, the KiCad Library Convention also requires us to have a chamfer on the side where the first pad is. But we created a box because it was easier to work with. Now we can go create from selection, create lines from selection, and then OK. Now we can work with these individually. The L chamfer should be around 25% of the package size, which is roughly 0.3 millimeters in our case. So I'm just going to edit the lines here. And so we can just do the math in this box. And then we can simply use the line tool, use the snap feature, and we have our chamfer drawn. We now also need to draw a pin 1 designator on the silk screen layer. I'm just going to switch to that. And you can simply copy the chevron from another footprint in your clipboard and then paste it in your current one. So you don't need to draw it. Because KiCad is just text-based, you can see it's all the text stuff that just got copied. I simply copied the silkscreen marking from another footprint, and I can just paste it in here, rotate it, and select a finite grid. Make sure there's enough clearance. Yes. And that's it. Your custom footprint is complete and ready to use. If you enjoyed this series, make sure to follow us for more PCB design tips and KiCad tutorials.